first LEGO League, FLL, I will actually be arranging 2 guest speakers from the Los Angeles Regional Championship and also from North Texas. So they are actually judge advisors for the entire region, and they're going to be coming over, and I've told them to prepare some slides and to teach you about the secrets of judging, FL judging, secrets to how to do well. And then after that, we have Introduction to Computer-Aided Design, so CAD. We have FTC programming workshops. We have more FL workshops. We want to be able to teach you more about project presentations, about robot presentations, what to have for those presentations, about core values. And then about, a lot of people are asking me, a lot of people were messaging me about robotics and artificial intelligence. So this topic is really interesting. I will have possibly one of my friends that's an MIT programmer that's working on machine learning and artificial intelligence come and give you a talk about artificial intelligence. We also have coding. If we have time, we'll touch on coding Scratch. We'll also talk about mechanical engineering and speaking to judges. So around maybe every week, we'll have a different topic. So, yep. So this week, let's see what I have on these slides. Okay, so before I would like to do anything, I want to say thank you to all the volunteers. Some of them are with us today. So, for example, Walnut Valley Robotics, Team Sprocket, and I have only there is 3 more FRC and FTC teams, but we actually right now have 5 more FRC and FTC teams, and
bad people here as well.
And in the future, we will have they're here. Those teams are here watching. So so to some of you that are asking me right now, there are high school kids in this conversation here watching you guys too. So yeah, so they will be teaching you guys about those topics. And in here, we're partnering with Coderina and Futureproof. So thank you guys for helping us in setting this all up. So to some of you that don't know how to use Zoom, so today is an orientation meeting. So if you have any questions whatsoever, I see a lot of people already know how to use the chat feature. So on the bottom, like the 3rd button, I don't know if it's the 3rd button for you, but here we have the chat. So you can click on chat and you can message if you have any questions, if you want to speak out, if you want to talk, if you want to ask a question, message us. So right now I have around 5 or 6 assistants here to help me that will answer questions. If you need anything, they'll respond hi. Yep. A lot of people are just messaging right now. Yeah, so use the chat feature. If you want, if you can't chat, just use yes, no, go slower, go faster, and we will talk to you. Okay? So one of us will talk to you. So hi everyone. Yeah, so let's move on. Sorry, my slides is very slow. So I'm just gonna give a very, very brief introduction to engineering. So to prepare you guys for next week and the week after, so the high school students don't have to really do much to tell you about engineering. So when I search up engineering on Google, they say engineering is the branch of technology concerned with design, building, and use of engines, machines, and structures. And then when I search on Wikipedia, it has an even more boring answer. It's the engineering is the use of principles to design and build machine structures and other blah, 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 blah items. And then, but what I say is, it's almost everything. You're creating the future. You're inventing the future. You're creating stuff from rockets to for even generators or even cars. Engineering. That's what all of engineering is. And by the way, today is SpaceX's and NASA's rocket launch. So it's around, I think, 4 p.m. or around that time in the local time zone in Florida, so Eastern. So if you have time, go, or if you're awake, go watch this launch. So engineering is a very wide field. So from acoustic, I'm not going to read this entire list, but like acoustics, aerospace, we have civil, we have computer engineering, we have electrical engineering, we have electrical, we have vehicle, we have nano engineering, all these different types of engineerings that you can be working with. Let's see. Sorry.
Good afternoon,
Okay.
sir.
Good afternoon. How are you?
I'm fine, sir.
Good. What's your name?
Feidara.
Okay, nice to meet you.
Sir, hello, please, what subject is this?
This is engineering. So today I'm just going to be talking about engineering careers. So engineering careers, so as I said before, we have stuff like aerospace engineering. That's what I do. I am helping research about planes, so about wings. So how does air flow through a wing? How does air flow around the wing? And that other stuff. And how air goes into the engine. That's what I do. But we also have a lot of different types. So like civil, so like building bridges. We have computer programming. We have mechanical. We have chemical. We have electrical. So all these, we all work together to create one big product. Let's see. So, so to talk about chemical engineering, I'm just gonna go in a super basic concept. So basically chemical engineering is to scientifically apply chemistry, physics, and design. Some chemical engineering is very important for like rockets, reactors, and boosters. So like, and also within the medical field. I apologize. Am I talking too quickly? Sorry. Or maybe it's...
Sorry.
Are you guys understanding me?
Yeah, we can hear you.
Yes,
okay.
we can hear you.
Okay,
yes,
good.
sure, we can hear you.
Okay.
Yes, sir.
So we're doing a lot about the chemical engineering is one of the most important. So for example, when we launch a rocket, we have to decide what propellant so we need to put fuel into the rocket, right? So we need to decide how to mix up the fuel, also in your cars as well. So civil engineering, so those are the people that will build your roads, that will build bridges, that will build buildings, that will build infrastructure, they'll build your homes, they're architects, they're designers. So that's a lot of civil engineering. Electrical engineering. So these days, these are the important people, because everyone has a cell phone, right? So these are the electrical engineers that are making your phones. Other examples is motors, generators. So these are the people that will be having that will be making these. Sorry, people are asking me a lot of questions. And then we have, yeah, so basically electrical engineers are making your jams. Yes.
Ken, I think we maxed out. It's
we
only
maxed out 100.
Yeah,
okay.
We maxed out 100.
Okay.
Yeah.
I need to talk to our IT department.
Don't worry. We'll sort it out for the next one.
We'll
Let's just keep going. Yeah, we'll share. Yes. You send me the presentation. I'll share it with everybody, and then we'll take it from there.
Yeah. Because this week is only the introduction. It's orientation. It's just to test out this this
I'll
feature.
share the video. I'll share the presentation, and everybody will be fine.
Yeah. I'm also streaming it on YouTube right now. So if you wanna. Okay. So let me continue. Okay, so mechanical engineering, just to really go quickly over this. These are the people that are making a lot of what we're actually doing. So for example, they're designing designing water bottles. They're designing lamps. They're designing. I'm just looking around my room. They're designing the printers. They're designing the engines. Yeah. So if you they're designing fans. They're designing. So mechanical engineering is a very wide range, and they're like the inventors. They're the people that are making your product physically. So just a quick overview on other types of engineering. We have agricultural engineering, we have architectural, we have biomedical, we have computer engineering, and industrial engineering. So I have some pictures here of just different fields of engineering.
Can I ask a question?
Yes.
What's the difference between mechanical engineering and computer?
So mechanical engineering is the people. Computer engineering is there. It's computers. It's in the name. So they are more like the people that will build your computers. They're people that will program. Those are we say a lot of computer engineers are those that will. It's more computer science too, but they will program. They do a lot of programming. Do a lot of Java, C++, all that different stuff. But computer engineers build your laptops. They design your laptops. But mechanical engineers, those are people that will build your engines. So in your car, they'll design your car. They'll build the car. They'll do bigger things. Does that answer your question?
So thank you for that
Yeah,
question.
thank you. Yeah.
So let me just add to what Ken said. So mechanical engineers design, develop, and test physical.
Hello?
I think there's a network issue.
Yeah, I think there's a network issue. So is he still? Okay, I'll continue then. Okay, so yeah, but mechanical engineering does between mechanical engineering and computer engineering. Did I answer your question, or do you?
Yeah, you answered it. Thank you.
Yes. Okay, no problem. If you have any questions, anyone have any questions, message me. So, for example, hi, who makes the chips? So chips are made by a combination between computer engineering and electrical engineering. So chips are very complicated. If you want to learn more about computer chips, you can talk to me. I will send you. I'm gonna actually put out an email. I'm gonna put out the robotics email in our group chat in the chat right now. You can. Let me send it out here.
Excuse me, I have a doubt.
Okay, sorry.
Yeah, I have a doubt. Oh, what does a PCI Express slot mean? Like, what
Sorry,
does it do?
I can't hear you. Can you type in the chat? Because I can't. It's cutting out.
Sure.
Yeah. So let me see. Let me see what petroleum engineers. So those are the people that are on those rigs in the ocean usually that are getting petroleum. They're designing methods to extract them actually. So between mechatronics and robotics. So those two fields are actually very similar. So robotics engineering is a lot of to do with it's a more wide range scope with programming and fabrication, so making of the robot. But mechatronics is a lot so is a lot to do with the movement, so actual physical movement. So what we do in well, in university is we are calculating how an arm moves. So it's almost the same topic, but it's basically, I would say, the same. But mechatronics is how, for example, how an arm moves. Yes. So.
Excuse me?
Yes.
What is the difference between architectural engineering and the civil engineering?
So architectural engineering is so mainly I would say people that do architectural engineering are people that are designing the building. So for example, let me see. Let me have. Actually, can I draw on my screen? I wonder. Let me try. Let me try drawing. Yeah. So I would say, so when we're building a building, we have. So let's say this is our building. Okay. So for example, we have a lot of different calculations. Let's say, for example, this is the structure for a building. Yeah, it's not engineering. This is not actually a building, so don't quote me in the future. So so let's say this is the structure to the engineering. This structure is what sorry, this is what architectural engineering. So people will design, the appearance of the structure will be made by architectural engineers, and it'll be up to the civil engineers that will do the force calculation to say, will this building like stand? Will this building collapse? If you get what I'm saying. So this is what architectural designs, the kind of the appearance, and then civil engineering will make the calculations to say, oh, will this building like stand? Okay, actually, I have more than like 10 people.
Software engineer do?
Software engineering, actually, maybe we'll come back to the end. So like maybe like 10 other people are privately messaging me to ask me questions.
You just carry on. I'll be responding. If you have any question, put your question in the chat and I'll respond to it in chat. Yeah. Okay.
Yeah, because 10 different people are messaging me, asking me different things.
And don't message Ken privately. Put all your questions to everyone, so we can send the answers to everyone. Okay.
Yeah. But it's very good that you guys are all very interested in the different careers, the different engineering careers. Yes. So also just to talk about this, because I think 3 or 4 people asked me about artificial intelligence. So I'm just gonna go over very quickly. Sorry, I need to clear my screen. So artificial intelligence, I'm just gonna, one of the robotics teams or my friend at MIT will talk more about this. But artificial intelligence, just to give you a brief idea, is basically I don't know if this might be too advanced, sorry, but it's basically, if you see, I have a graph of plots, right? So how robotics relates to this is artificial intelligence. Basically, we are finding a line. So if on the graph, we're finding a best fit line. So that's what we're basically doing. And then the robot or your machine will use machine learning. It's a very complicated topic, so I'm sorry if I'm making it very complicated too, but it will.
I have shared the definition of artificial intelligence. So
yeah,
Ken, just keep to the.
Okay. Yeah. Sure.
Just go on with the slides.
Yeah.
I'll be dealing with the questions.
Yeah. So sorry about this. All this. Sorry. Okay. Okay, so next week, so this is mainly most that I have for you, but now I'm gonna kind of go over what they're doing next week, give you an introduction, so maybe you can start studying, you can start looking. Yes?
Can you please explain chemical engineering again?
I'll explain it maybe later after the meeting, after when everyone leaves, or you can put it in the chat and they will respond to you.
Put your questions in the chat and I'll answer your questions in the chat.
Okay, good?
Yep.
Okay, thank you so much. Okay, so next week they'll talk about simple machines. So what are simple machines? They're basically things that we design our objects out of. For example, we start with the lever. Oh, I'm muted. Hello?
Yeah,
Okay.
go ahead. Yep.
Yeah, okay. So we start with the lever. For example, in this, I think this is the transmission, where we start with a wheel and axle. So this is a Ferris wheel. We start with a pulley. And so in this picture, we're using a pulley to pull up a plane. So it's really, I'm just gonna give you kind of simple, this is what we're doing next week. It's a quick introduction. So here we have the inclined plane. Here we have a wedge. So for example, this firefighter is using his axe. So on the end of the axe here is actually a wedge. So it's like, so it's kind of like this. So this is like a wedge. So if you had a piece of wood here, you want to use a wedge to break, to chop open the wood. Here this part is the screw. Yep, okay, so we have the screw, we have an inclined plane here. So this is a roller coaster. I don't know if you've been on a roller coaster. So yeah. Okay, so let me move on. Next week, they'll also be talking, I won't go step by step into this. I'll let the high school students go in, but I thought it might be nice today to just quickly go over the design method. So if you want, you can take a screenshot of this. This is in first, we really suggest you to use the design method, just not to create your ideas based on Scratch. Just go through an iterative process. So if you want to, I'll let the high school kids, I won't really talk much about this, but I'll let the high school kids talk more about this. So yeah, so essentially we're designing. So here's a simpler diagram. So we're defining the problem, we're generating concepts, we're developing a solution, we're constructing and testing a prototype. Then we're gonna evaluate, does our solution to that problem work? For example, if I say, I want to make a robot that shoots balls into a goal. So does that, we're testing whether or not, does that robot, if I create a shooter, does that robot can that robot shoot a ball into the goal, and how fast that robot can shoot a ball into the goal? So that's what we're kind of checking here, okay? Then if the product works, we present the solution. That's when we go to competition. So for example, and if some of you might be from FLL, so that's when we go to competition. We're presenting our solution to judges. We're presenting our robot to, we're competing our robot. Okay, we'll continue here. Another different ideas that we're working with is documentation. So this is very important for FTC and FLL, especially when you go to world championships or if you want to compete in the United States. I don't know how important it is in your local country, but for example here, documentation, they'll go over some basic engineering documentation rules. So for example, what to have. So like documentation is basically, we put in all our research, we put in our work session summaries. We type in, for example, if you look at this example alone, they have like diagrams. They have, oh, hey, what does this diagram do? What am I doing today? And then here, they put in their findings, and you see this is all on graph paper, and the graph paper is special because it has a lot of information here. We have a lot of the titles. They have all the documents. So for example, this is important when you enter the engineering industry because people want to sometimes steal your ideas. So it's important to follow this process. Okay, so keep going. Sorry about if I'm going over time too. I was only planning to do like 30 minutes. yeah. Okay, so I think this is almost the last slide. So other stuff we can put in documentation is, for example, CAD printouts. No. Okay, so CAD printouts. So for example, here we have, this isn't really a CAD, it's just a photograph. So, and then we put in our calculation. So this is what we want to be putting into our engineering books. And for first robotics, this is very important for judges. Judges want to know about this. Yeah, so let's see. Okay, so I think if you guys have any other questions, so today, I'm sorry today if today was really rushed, and usually it's not me talking, it's the high school students talking. What is CAD? So CAD is computer aided design. So as someone else said it, they use AutoCAD. So your dad uses AutoCAD in work. So AutoCAD is basically using a computer to create your object. Let me see if I have any pictures of it. Do I have any pictures of AutoCAD? I don't know. Oh, so something maybe, this might be somewhat AutoCAD. Well, this is a computer-aided drawing, so that might be. And then what we have in the corner, but this, yeah. So, but this isn't really. It's kind of AutoCAD. There's some. It's not AutoCAD, but it's like a CAD drawing. Okay, so if anyone has any other questions, I'm gonna put the email into there. Let me put in the email into actually, we're at 119 participants, so okay, yes. So if you have any other questions, so let me, Alice, can you actually post the YouTube video link on here?
Yep, please share the YouTube link.
So actually, one of my students suggested that if you have any questions, comment on that YouTube video and we'll reply. We'll reply to it. I'll have the students will reply to. So if you have any questions about your careers, about jobs, I will personally reply to him. I will have also my students will reply to them. But let's see my presentation. But next week, so next week it will be the same time, Saturday. So so if it's 3 p.m. Ghana, 4 p.m. Nigeria, 5 p.m. We have some people from South Africa and Egypt. We have 8:30 p.m. India, and then I'm in Hong Kong, so I'm 11 p.m. and we have students in Los Angeles at 8 a.m. So next week we'll be talking about introduction to engineering. So kind of what I went over, basic concepts, design, and yeah. So if you have any questions about, yes, we will get serious next time. To someone that's saying that. So today is just very overview. We're testing our software. So any other?
Today is to just basically to give you an overview of engineering concepts, engineering design, because it doesn't make sense that you go straight into robotics if you haven't done anything robotics before and you don't have the, oh, sorry, I think the bandwidth. So if you don't have a good understanding of robotics or engineering concepts, what's happening?
Hello?
Hello? Okay. I want to ask about, please can you explain to me about mechatronics?
Oh, actually here, let me actually reply into, yeah, you want to know, do you have a specific question? Because I think if it's just about the field, I can explain it to you I'll type it out and explain it to you in the.
I want to know everything about it because it's just based on my career and that's what I want to do in future.
You want to be that. So as let me see. So let me think of it because I haven't really. Let me give me 1 second. So are you in robotics?
Yes, I went for last year's first legal league.
You're in first legacies.
Yes.
Yes. So
That's my school.
So so basically that's the design of systems, so integrating systems. So it focuses a lot on robotics and we all the time always know. Can anyone hear me without the static? Or does anyone hear the static too?
I hear the static too.
Okay, I'm just gonna mute everyone. I'm just gonna mute everyone just to get rid of the static. I think it's gone, right? So let me see. Let me see if I can find a quick video. Let's see. Okay, let me screen share a new share. Let's see if I can open that. Ah, here. Okay. So if you look at this, can you guys see this? It's a YouTube video. Oh, yes. Everything you want to, so stuff we'll be learning, we'll be doing is a lot related to our to FLL. Everything we do is mainly related to FLL and FTC. So some people are asking. So to someone that is asking about mechatronics. So do you see how this arm moves? So this robotic arm, or how this this system works. So that's how it's kind of. Yes. So good. Thank you. You posted a video. Good. Okay. So other questions you ask. Let's see. FTC and FL, I think the students can help me answer that. So FTC, so first is a robotics program that from ages between kindergarten up to high school. So FL is more for elementary school, primary school. FTC is for it's for primary and junior high school. But I think in your country, most likely it's for junior high or older. Yeah. So yeah, any other questions? I think if Alice can post the link. Is FTC compulsory for no?
FLL.
Yeah, if you want to answer that, I think you're
so,
better at answering this than I am.
So FLL is it's a program that helps kids, to young people like yourself, to think like engineers, like inventors, like creators. It's for young people ages. So we have somebody trying to hack us. So it's from for kids between the ages of 9 to 16. And we teach you basic concepts of engineering, basic robotics design, building robots, programming robots. And we do that with schools in Nigeria already. So if your school is not involved, send a message to to us here, and we'll note your school down, and we get somebody to talk to your school. First Tech Challenge is for young people between the ages of 12 to 18. It's a little bit more advanced than First Lego League Challenge. It's to teach engineering concept at a higher level than you would teach them in First Lego League. You'll be exposed to engineering design, you'll be exposed to engineering processes and a lot of different things that would help shape your career if you're looking to do engineering. So I think we have some hackers on here trying to write on to doodle on what you're doing.
Okay, so if anyone has any other questions, I think we can comment onto the YouTube link. So post your comments there, or send an email like to walnutvalleyrobotics@gmail.com. But I prefer if you guys comment on the YouTube link. We'll reply within maybe like 48 hours, let's say. Okay.
Right.
So
thank you so much, Ken.
No problem. So yeah, next week it's so next week it won't be myself. I will be in the chat, but I will be mainly moderating everything. I'll make sure everything goes well, but it will be the high school students that will be teaching you. So, and my goal is that you can be connecting with the high school students, and you can, well, hopefully also start a session where you can be one-on, I'll put you into breakout rooms and you guys can be connecting with them. So you can be exchanging contact information and you can be talking with them. Okay, so that's the goal of this all. So you guys can be learning from older engineers. Okay. Okay, so I think for today we're gonna end it here. We're gonna end it here. Where if you have any other questions, do go on into the YouTube. Go into the YouTube link and comment. Okay. Okay. Thank you so much.
Thanks everyone for joining, and see you next week.